Hello everyone, my name is Rohit Singhal and we were discussing about the hydrocarbons. In the previous class I have discussed about the some synthetic procedures of alkanes, how to synthesize them. I have discussed how to synthesize them from the unsaturated hydrocarbons by the hydrogenation reaction. Then I discussed alkyl halides that we have discussed again by the hydrogenation reaction adding the hydrogen molecule, but in the presence of different catalyst. Then I have started with the from carboxylic acid. We have taken the sodium salt of carboxylic acid and we have synthesized the alkanes in presence of calcium oxide and heating conditions. In that reaction, we have seen that one carbon is lost from the parent chain to form the alkane moiety. There is one another procedure we can use to produce to form alkanes from carboxylic acids only. So, there is another procedure. Okay, alkanes. So, there is one another procedure from carboxylic acids only, from sodium salt of carboxylic acid. Okay. One we have done is decarboxylation. I have already discussed in the previous class that was like this CH3CO minus. Okay, let's write it from the another pen. CH3COO minus Na plus. I have added NaOH, basic conditions, calcium oxide, heating, and it forms CH4 plus Na2CO3. Okay. This one another procedure is coal-based electrolytic method. Coal-based electrolytic method. Okay. You must have studied the basic fundamentals of electrolysis, right? There is one anode, there is one cathode. Okay, I will briefly discuss also for now, but you have done in the previous classes. Electrolysis. In electrolysis, there are two electrodes. One is called anode, another is called cathode. Anode is positively charged, cathode is negatively charged. If anode is positively charged, it will attract negative ions to it. And if it is a cathode, it will attract, as it is negatively signed, it will attract positive ions to it. Okay. What happens in on anode? Oxidation. Oxidation takes place. On anode there is always oxidation, on cathode there is always reduction taking place. So, reduction takes place. These two are the key points to remember for any electrolytic reaction. Okay. So, one thing, anode is positively charged, cathode is negatively charged. If anode is positively charged, it will attract the, as the opposite signs are attracted. So, it will attract the negatively charged, that is anions. Cathode is negatively charged, it will attract the positive ions to it, that is cations. Anode, there is always oxidation taking place on the anode. On cathode, always reduction takes place. Okay. So, now how we can produce from the help of sodium salts of carboxylic acid alkanes by this coal-based electrolytic process. Okay. So, what we do is salt is taken, CH3CO minus Na is taken. Let us suppose this only is taken. Okay. In this this is the stoichiometry will be 2 in this case, 2 molecules of this, and in the presence of water, and if we do the electrolysis of it, okay, let us write it in a better way. Electrolysis is done, what it will form is CH3. Okay. So, what happened in this case? Let's start with the electrolysis. Okay, there are two compartments. Okay, anode, another one is cathode. Okay. Anode is positively charged, cathode is negatively charged, will attract the negative ions. Okay. So, which one is negative? CH3CO minus. So, what will happen at anode? CH3CO minus will come. Okay. Now, what will happen? It will take up the 2 electrons, that is oxidation takes place. Okay. Oxidation anode means oxidation takes place. And what happens? Oxidation takes place, it is a positively charged, so it will attract CH3CO minus, this is the negative group. Now, oxidation means removal of electrons, so it will lose the 2 electrons. What it will form? CH3C double bond O, and it will form radical. What it will form? It will form a radical. Why I have chosen 2 electrons? Because I have taken the 2 substrates of this. So, one is to take electron from 1 minus. Okay, minus means there are 2 electrons. This represents the minus. Minus is represented. This minus sign means anion means 2 electrons. And 1 electron has been taken out from the anion, and it will give a radical. Okay. So, anion, removal of 2 electrons from an anion, or removal of an electron, 1 electron, will form a radical. Why the 2 electrons have been removed here? Because I have taken the 2 molecules of the this anion. Okay. Now, what will happen? I have formed 2 CH3CO radical, I have formed, right. Now, it will break into this. How it will break? This. Now, what happens is, this is notation to describe the bond when it is homolytic cleavage. I will tell you in a while what is homolytic cleavage. So, what it will give? It will give 2 CH3 radical. Okay. What it will form? A CO2. Okay. And this CH3 radical, 2 CH3 radical means there is 1 CH3 radical, 1 CH3 radical like this, 1 CH3 radical like this. Okay. So, there are 2 CH3 radical. What this radical will do? This both the radicals will give themselves up to form one bond. Okay. So, this will do one form, and it will form a bond, and it will form CH3 and CH3. Okay. This is how methane is formed. Okay. Ethane is formed. And what will happen at cathode? Okay, cathode H2O will go at cathode, because there is no other positive charge. So, what will happen? H2O will take up an electrode, and it will form OH minus and H radical. Okay. So, okay. Now, what is the thing? There is one interesting thing I have taught in this thing is, first is the anion. If 1 electron is taken up from the anion, it will form a radical. Okay. An anion means 2 electrons, and if I will take up 1 electron, it will leave the molecule with the 1 electron only, and that 1 electron species is known as radical. Now, I have done the homolytic cleavage. I have shown this homolytic cleavage. Okay. Okay, let me discuss about this cleavage, homolytic cleavage and heterolytic cleavages first. Let us take a general example, A, B. Okay. If I will do this arrow, this complete arrow, okay, then it will form, okay, bond is only of 1 electron. So, it will form A minus, because B has given electron. So, B plus. This is this is called heterolytic cleavage, unsymmetrical cleavage of bonds. It is unsymmetrical breaking of bond. Okay. In the other hand, what is homolytic cleavage, which I have shown in previous slide, is this half arrow. This is in half arrow I have shown. This is called a homolytic cleavage. What it will form? A radical plus B radical, that is symmetrical breaking of the electron. Symmetrical breaking, you can say, of bond, or symmetrical distribution of electrons of bond. Okay. So, this is what it mean by homolytic cleavage and heterolytic cleavage. Okay. So, this is homolytic cleavage, and this radical have okay, this homolytic cleavage of acetic acid, this radical of carboxylic acid has given us a alkyl radical, CH3 radical is given. What this happen is, these two CH3 radical have combined together to form an alkane and give the ethane molecule. Okay, to give ethane. What happened is cathode is negatively charged, there is no positive charge there, so it will attract the water molecule. Water molecule will take up an electron and will form OH minus and H radical. What happened then? H radical, this 2 H radical will combine to form a H2 molecule, and H2 is a gas. Okay. This is a gas. Okay. So, what will happen in this process? An H2 is released. Okay. So, in the electrolysis, there are two procedures we have seen from the salts of carboxylic acid. One is the decarboxylation method, in which we have taken the sodium hydroxide, the basic conditions we have taken, we have used in calcium oxide and in presence of heating conditions. What we have done, we have removed a CO2 moiety from the carboxylic acid and formed a alkane. In that case, we have got the alkane 1 carbon less than that of the starting material. What we have done in this another process from the carboxylic acid salts only, in this we have done the electrolysis known as Kolbe's electrolytic process. Okay. So, electrolysis I have told is consists of two parts. There are two main electrodes in the electrolysis, one is anode, another is cathode. Anode is positively charged. Okay. You can also see in this figure simultaneously, anode is the positively charged, cathode is negatively charged. Anode, if positively charged, will attract negative ions, that is anions, oxidation will take place. Cathode is negatively charged, will attract the cations towards it, and is reduction taking place on that. Okay. On anode, we have done the oxidation of the anionic part of the carboxylic acid. Okay. So, we have formed the coupling, and what will give the couple of it takes the coupling of the two moieties to give an alkane. Okay. So, if I take another example, if I will take example of, if I have to if I have to form, how to form, I form ethane. Okay. I have to form let us say butane. Now, how you going to form butane from it? So, what we have to take CH3 CH2 COO minus plus NaOH, sorry, plus H2O, this is Na, and we will do electrolysis, and it will form CH3 CH2 CH2 CH3. Okay. So, this moiety will couple this sodium salt, this CO minus Na will go as in the form of the carbon dioxide, and this will form, this will couple together. Okay. So, this process, however, is one of the most important methods and industrial processes used to synthesize alkanes in the industry, but these have got a few limitations. Okay. So, one of the most efficient methods okay, but these have got some limitations. Okay. There are some limitations of it. What are the limitations? First limitation, it can only form alkanes with even number of carbons, with even number of carbons. Okay. So, coal-based electrolytic process, what happens in coal-based electrolytic process, that we can form alkanes with having the even number of carbon atoms. Okay, because what's taking place in that is actually the coupling of the two moieties. Okay, whatever the radical is formed at the anode, it's a coupling of two, and whenever two moieties will combine together, it will always give an even number. So, we can't form methane from it. Methane we cannot form. Ethane CH3 we can form. Propane we cannot form. CH3 CH2 CH3 this we can form. Okay. So, these are the things with the even number of carbons we have formed, we can form this. So, this process is one of the most efficient methods to produce alkanes, but this is only limited to those which contains the even number of alkanes. So, till now, okay, so these are the only procedures which are required for you to study at this point of time. So, we have done from the unsaturated hydrocarbons, from the alkyl halides, then we have done two processes from the carboxylic acids. So, this sums up the procedure or the preparation methods of the saturated hydrocarbons. The next we can discuss is about the properties of the hydrocarbons. Properties of hydrocarbons, now we are doing alkanes. So, the properties of saturated hydrocarbons, alkanes. Okay. So, we will discuss about the physical properties of this, chemical properties of this. In general, what happens that the saturated hydrocarbons, alkanes are the carbon and hydrogen only, and these are not reactive, too much reactive. These are resistant to the acids and base. So, these generally react easily, but in what conditions do they react, what are their physical properties, how they look like, what are their other physical properties, melting point, boiling point, their solubility, that we will discuss in the next class. So, for now onwards, discuss this, practice these questions, learn this thing, and yeah, thank you so much.